Hello and welcome to the week 12 CSM video walkthrough. And today I'm going to be going over replace leave sum, which is the second problem in the tree section of this worksheet. So let's get right into it. The spec says given a tree T, mutate the tree so that each leaf's label becomes the sum of the labels of all the nodes in the path from the leaf node to the root node. So let's kind of look at the doc test to give us a better idea of what we're going to be trying to code out. And so let's draw out T in the natural tree form. So we see the root node is a 1. And on the next level, there's going to be a 3, which has another level as denoted by another bracket of 2 and 8, which are lone leaf nodes. Okay, and then we kind of exit out of this level altogether, and we go back to the level of 3, because there's another closing bracket here. And on the same level, we're going to have a 5 leaf node. Okay, so we're going to call replace leaf sum on T. And we see that nothing is being returned from this function because we're mutating T. And so when we call T again, we see that the new representation is going to be 1 again, 3, and now we're going to have a 6 here, a 12 on the other one, and a 6 here. So we can see that all the leaf nodes have been changed, and these two other ones have been unchanged. Okay, so let's kind of see a better intuition for this. Well, we know from the spec that each leaf's label changes and it becomes the sum of the labels of all the nodes in the path from the leaf node to the root node. So 2 turns into 6 because 1 plus 3 plus 2 is equal to 6. 8 turns into 12 because 1 plus 3 plus 8 is equal to 12. And 5 turns into 6 because 1 plus 5 is equal to 6. So we see that there is something accumulating, and that we should kind of keep track of a variable to accumulate as we traverse throughout the tree. And also notice that we're also adding up the value in the previous leaf node itself. So we're not just adding 1 and 3, we're adding 1, 3, and 2. So we'll need to access this leaf value somewhere in our function as well. So if we take a look at the skeleton code, we see that there is a helper function that is given to us to use. And so, like I said previously, it will be helpful in keeping track of the total as we traverse through the tree. And so a helper function will allow us to add in another value and kind of track this value as we make our recursive calls. So we know that we're going to be returning, not returning. We're going to just be calling helper here because we're not returning a new tree. We're going to be calling helper, and the first thing we should pass in is the tree because we're trying to mutate the tree and not return a new tree altogether. So we need to pass it in order to change it. And so we pass it in to change it in helper. And like I said previously, we need a total variable to keep track of all the values accumulated. Okay, so now that we got that down, we can actually look into the helper function and try to mutate this tree. So when we get to the part where the tree is a leaf, we know that we want to mutate it, right? So we have the total, we have whatever has come before this, and that's a little leap of faith I'm taking here. Let's say total is everything, all the work we were supposed to do leading up to getting to a leaf. And so we found that the total is 4 in this case. And now we want to mutate the tree so that the leaf value is changed to a 6. So in this case, we know that T is a leaf. And so we want to change the T dot label, which is the label of this leaf, to a new value. So we know that we want to assign this because we're mutating. And say that we make the assumption that total is the work that we've done leading up to it. So say it's 4. And we know that from the spec and the doc test that we want to also include the value of the leaves in our final sum, which is 6. So it's 1 plus 3 plus 2. And so 2 is the current T dot label. And we're going to reassign this final value into the new modification for this node. So now T dot label in the mutated tree is going to be 6. And likewise for this other one, it would be 1 plus 3 plus 8. So we see once it hits the 8 mark, it's going to add up 4 plus the current T dot label, which is 8. and assign it into our new label. So hopefully that's super clear and understandable, because now we have to do all the work leading up to it in order to find the total value that we need to tack on to our current leaf value. So this the skeleton gives us a 4b and t dot branches. So this is a way for us to traverse throughout all the branches in the tree. So for every branch in t dot branches, which can be this branch and then this branch and then this branch, we want to be able to do something. Well, we know that it's going to be a recursive call to helper because we need to keep accumulating down the tree. So we're going to call helper again. And the first value is going to be every branch, because that is the next subproblem that we're going to try to traverse down into a leaf. So in the next iteration after the root node of 1, we're going to get into this branch all the way down into this leaf, and then we're going to get into this branch all the way down into this leaf, and finally into this branch, and this is already a leaf. So hopefully that kind of clears up the intuition behind this for loop. And so we're trying to kind of create a subproblem, which is B, every branch, and try to accumulate from there. So now comes the accumulation part. So we know that we have total. So we sorry, I'm so sorry. This should be 0 because we want to start total equals to 0. I got a little confused there. Yeah, this should be total because that's a variable, but this should start off with 0 because we're trying to start and count the accumulation. So if total is equal to 0, first, we can assume that every time we're updating this variable, it keeps accumulating. So how do we accumulate? Well, we know that we want to pass in a new total plus something that will accumulate all our values. Well, if we're in this new branch, B, say we're in this branch, we want to accumulate total plus the current value that we're on. So when we're in the next branch, we can keep going down and accumulate all these values on the current branch. So total plus t dot label is what we're looking for. Okay, yeah, so sorry about that. It should start off with a 0. I did not notice that until very late. So hopefully that didn't confuse you too much, but yeah, we're gonna start accumulating with 0 because that's what we do when we try to accumulate values. Okay, yeah, so this is the correct answer. Just as a sanity check, I'm going to go run through it again to make sure everything's looking correct. Okay, so so we start off with this tree. We call helper, we call total equal to 0, so we sign it in order to accumulate our values. And so we enter helper function, and obviously in this iteration, t is this entire tree, and it is indeed not a leaf. So we go to for b and t dot branches, and so we look at the branches individually, and we call helper again on a branch this time, so it's going to be a new little tree. And we're going to keep accumulating total, so 0 plus t dot label, so whatever this label is. And we're going to accumulate that all the way until we reach the clause where t is a leaf. Then we're going to add on total, so we've already done all the work from the previous parts, add it on, and then reassign it into what t was before. So in this case, t is mutating, we're not returning any new tree constructor. And yeah, so here we're creating a little recursive loop of faith because obviously we don't really see what's happening after. We kind of have to assume that our function works and keep on calling that on each of the branches and t dot branches. But yeah, so we kind of create a subproblem for b and t dot branches. We whittle down into all the smallest subproblems, and that is how we get our final solution of a new mutated tree. So yeah, hope that helped. Sorry about that little mix-up there. Other than that, I hope that this video was helpful. Thank you.